Dr. P here. I want to talk about what things look like, what graphs look like, what the acceleration, what the velocity is of a ball that I throw up in the air and it comes straight back down. And so the first thing I want to do is draw a position versus time graph of this. I think this is something that makes sense to you probably already if you've been paying attention and watching the rest of the videos. So the position versus time, it's going to change rapidly over the first part of the motion, then the object is going to slow down, and then the position is going to decrease with time. So you get this nice symmetric bottom opening parabola to describe the motion of this object. And the important thing to note is that I always am going to have up be positive. So when I look at this position versus time graph, there's a few things that I want to draw to your attention. The first thing is that if this takes a total time t, then at the top of its motion, this is going to be t1/2. So this total time in the air that the ball spins going up and coming back down, it takes half the time to go up and the other half the time to come back down. So if I were to draw some snapshots of the ball as it's going through this at just random points throughout the motion, here's the ball as it's going up and here's the ball as it's coming back down. The one thing I want you to make sure you understand is that these two balls are at the same height, these two dots are at the same height, and these two dots are at the same height. I want to talk about the velocity of this ball as it goes up and as it comes back down. And so remember, this ball is going up and coming back down, so the ball isn't traveling sideways, it's going up and coming back down. And the only reason this looks like that I'm throwing it from one person to another is because I'm graphing the position versus time. So time is moving on as the ball is falling. And so the velocity starts off down here, and it starts off big and positive. And then over time, this velocity will decrease until it gets to the top of the motion where the velocity is 0. And then as the ball comes back down, the velocity will get bigger. If the ball is at the same height, it's going to have the same speed, but opposite directions. And so the arrows at this height and this height will be the same, just like the arrow at this height and this height will be the same. So the speed is the same going up as it is coming back down, how it changes over time, but the velocity, it changes directions. Okay, so what about the acceleration? Right? What's causing the ball to change its motion? Well, the acceleration is because of gravity, because the earth is pulling on it. So you're talking about the force of the earth pulling on this object. The earth or gravity pulls on the object in the same direction, whether it's going up or whether it's going down, it's always going to pull on this object downward. And so when it's slowing down, it's pulling downward on it, and when it's speeding up, it's pulling downward on it. And the important thing to note is that this acceleration, due to gravity in the blue, this acceleration is the same. It is constant and down. Okay, so you throw up the ball with some velocity, it goes up and it comes back down. So this velocity v here is this velocity negative v here. Half the time to go up, half the time to go down. Velocity at the top is 0. So the motion of this object as it's coming down here, that's the same as if I were just to take any object, if I were to take a ball or a different object, and I were to drop it. So if I were to drop a ball from the same height, its position versus time graph will look like the second half of this motion. Now, it will start at 0 and it will do this. So just like when you have a cart on a ramp that goes up and comes back down, this motion looks very similar to that motion, as long as you have down be the negative direction or down the ramp be negative. So this object, this ball, will start off with a big positive velocity because you're throwing it up in the positive direction. Then as it travels up in the air, the velocity at the top becomes 0. And then as it travels back down, the velocity down here becomes negative. And so when you look at this, the important things of this graph to take away are this, if this is velocity versus time, this velocity up here is the same as this one, but this one's negative. This would be the total time, and this would be half the time. So this area is your displacement. It is going to be the same amount as this area is, which is the displacement because it travels up a height of, let's say, h, and then it travels back down that same height. And so these displacements are going to be the same, but this one is going to be negative. And when we look at the acceleration versus time then, the acceleration, remember, gravity is always pulling on it downward. It's given by these blue arrows. Acceleration is always going to be pulling down. It's going to be negative, and it's going to be constant. The one thing you want to make sure that you don't do with the acceleration graph is think, oh, well, it's slowing down as it's going up, right? It's going up and it's slowing down, so that slowing down means negative velocity. And as it's traveling back down, it's speeding up. Speeding up means positive velocity. This idea, this is wrong because the acceleration is always going to pull it downward, so you're never going to have a positive acceleration. So objects that are traveling downward can be speeding up. They can have negative acceleration and be speeding up. And that is the example of you drop something. And remember, this is going to be just 10 negative if our units here are meters per second squared.